Hello friends, welcome in this new video. Friends, in this video we see about the interpolation and extrapolation of a function. Friends, independent variable are x equal to x0, x1, x2, x3. These are the value of the independent variable. At the same time, a value of the dependent variable are f of x0, f of x1, f of x1, f of x2 and f of x3. These are the values of the function. In particular, if we take 1, 2, 3, 4, this is suppose the value of the function, and 5, 10, 15, 20, these are the value of the function at this particular point. Then sometime it is asked to find the value of the function at 2.5. Then here the domain of this function is from 1 to 4, and the value of the function, it is not closed interval, uh, since it do not contain all the values lies between 1 to 4. But for our convenience I have written like this. Value of the functions are particular for we have taken 1, 2, 3, 4, only these 2 points, not all the points lies between 1 and 4. Remember this thing. So but the value of this x is in this domain 2.5 lies between 2 and 3 of the given value of the x, and this is an intermediate value of these 2 points. So this type of value of finding the function at 2.5 is called as an interpolation. So interpolation means finding an intermediate value, or inserting filling up an intermediate terms of the function. Sometime it is asked to find the value of the function at suppose 4.5. Then you can see that this is beyond the domain of this function, and this type of point finding the value, this type of problem is called as an extrapolation. This is an extrapolation. This is not in the domain of this function. Similarly, whenever we need to find at 0.5, then this is also not is in the range of this domain values of the function independent variable. So this is also called as an extrapolation. And for all values lies between 1 to 4. Sometimes it is asked to find 3.1. So 3.1 lies between 3 and 4 of the independent variable. So finding this value is called as an interpolation. So this is a concept of interpolation and extrapolation. Now we deduce here the Newton-Gregory forward difference formula. Suppose that the value of the independent variable x are a plus h, a plus 2h, a plus nh. H is the interval of differencing, and the corresponding value of y are f of a plus h, f of a plus 2h dash dash, f of a plus nh. Now let us consider the polynomial of nth degree. Suppose the polynomial is like this: a0 plus a1 into x minus a plus a2 into x minus a minus h plus a3 into x minus a minus h, x minus a minus 2h plus an into x minus a minus h up to x minus a minus n minus 1 into h, where the coefficients a0, a1, an are so that so that Pn of A equal to f of A. uh, Pn of A plus H equal to f of A plus H. Similarly, the polynomial at A plus nh equal to f of A plus nh. So the coefficients are determined. We determine this A0 uh, constant an are so that we determine this so that whenever the Pn of A equal to f of A, Pn of A plus H equal to f of A plus H, and Pn of A plus nh equal to f of A plus nh. Superint, remember what we have taken? We have taken the values of independent variable, we have taken value of independent variable, and we have considered one polynomial of nth degree. Pn of x equal to a0 plus a1 into x minus a plus a2 into x minus a into x minus a minus h plus a3 into x minus a, x minus a minus h, x minus a minus 2h, like this. And here a0, a1, an are constant, and these are determined so that whenever the Pn of A equal to f of A, Pn of A plus h equal to f of A plus nh. Now what we do here, we put x equal to a comma a plus h comma a plus 2h successively in equation number 1 in 1. So let us put first x equal to a. Whenever we put x equal to a, we get Pn of A. So but Pn of A equal to what? F of A equal to a0 plus. Now whenever we put x equal to a minus a will get 0, so this term will be 0. Here again x minus a is a factor, so this will be 0. X minus a is factor, again this will be 0. Everywhere the all terms except the first contain x minus a as a factor, so all will be vanish and we get simply a0, and we get the value of a0 as f of a. Now let us put a plus h, x equal to a plus h. Then left hand side Pn of a plus h equal to here we have considered this side f of a plus h equal to a0 plus a1 into x are here we putting a plus h minus a plus. Again you can see that whenever here we put x equal to a plus h, a and h get cancelled and this will be 0. So everywhere x minus a minus h is a factor, so all other remaining terms will be vanishes. This is equal to a1 into h, so all other terms are 0, and a0 is nothing but f of a, so we write this as f of a plus h minus f of a equal to a1 into h, or a1 equal to, this is what, this is by, remember the definition of delta, this is nothing but delta f of a divided by h, so we get a1 equal to delta f of a divided by h. Now let us put x equal to a plus 2h. Pn of a plus 2h, so this will be f of a plus 2h equal to a0 plus a1 into a plus 2h minus a plus a2 into a plus 2h minus a plus 2h minus a minus h plus all the remaining terms due to this factor x minus a minus 2h will be 0. A plus 2h, f of a plus 2h, f a0 is nothing but f of a, so we write it as minus f of a0 plus here you can see that this will be twice h into a1. Let us put the value of a1, this is f of a divided by h and h will be cancelled. Now here a2 into 2h this, and a get cancelled, 2h minus h, this will be h. Okay, Now let us transfer this term and here a2 into h square 2 into 1. So this is a2 into 2 factorial into h square equal to f of a plus 2h minus twice delta f of a. Delta f of a is nothing but f of a plus h minus f of a minus f of a. F of a plus 2h minus 2 f of a plus h and minus minus plus 2 f of a plus 2 f of a plus f of a, and this will be minus f of a, this will be plus f of a. But this is expansion of delta square f of a. So we get a2 equal to delta square f of a divided by 2 factorial into h square. Similarly we get here similarly delta cube f of a divided by 3 factorial h cube will be a cube, and the general terms will be delta raised to n f of a divided by n factorial into h raised to n, and this will be our a n. So in this manner we have obtained all the values of the coefficient a0 equal to f of a1 equal to delta f of a divided by h, a2 equal to delta square f of a divided by 2 factorial h square, and in general an equal to delta raised to n f of a divided by n factorial into h raised to n. Let us put this value in the given polynomial equation number 1. Then Pn of x Pn of x equal to here what is a0 is f of a plus a1 is nothing but delta f of a divided by h into x minus a plus a2 delta square f of a divided by 2 factorial into h square x minus a minus h plus a3 divided by 3 factorial h cube into x minus a minus h x minus a minus 2h plus and an is delta raised to n f of a divided by n factorial h raised to n into x minus a minus h x minus a minus n minus 1 into h. So this is the Pn of a, and this is called as a Newton-Gregory forward difference formula. Now for simplicity we put here u equal to, let us put in this formula u equal to x minus a divided by h or x equal to a plus u into h, right? Then x minus a minus h, this will be you can see here x is nothing but a plus uh minus a minus h, so a get cancelled and uh this is equal to u minus 1 into h. So here x minus a minus h divided by h, this is nothing but u minus 1. Therefore this h square x minus a divided by h, this will be u and this will be u minus 1. So this term Pn of x is nothing but Pn of a plus uh equal to f of a plus u into delta f of a plus u into u minus 1 divided by 2 factorial delta square f of a plus u into u minus 1 u minus 2 divided by 3 factorial delta cube f of a plus u into u minus 1 up to u minus n minus 1 up to divided by n factorial into delta raised to n f of a. This is the simplified form of the Newton-Gregory forward difference formula. So friend, the process is very simple and you have seen how we have obtained the result of how we have deduced the Newton-Gregory forward difference formula. I hope you have get the idea and you you can deduce the Newton-Gregory forward difference formula. Thank you friend, thank you for watching the video. Keep watching. I will upload more and more videos on this numerical analysis. Thank you once again.